In this video, we are going to be going over lesson 6, which talks about different addition properties. The first addition property that we are going to be going over is called the commutative property of addition. Now, what the commutative property is when you are switching the order of your numbers, and even though you're switching the order, you're still adding them, so your answer will still be the same. Okay, so here are two examples of what that could look like. On this first one here, I have 8 plus 10, and if I were to switch the order, I'd have 10 plus 8. Regardless of whichever number comes first, I'm going to get 18 both times when I add my number. Down here is another example with three numbers. So I have 4 plus 13 plus 10. So I have my first number, second, and third. When I reorganize them over here, they're in a different order, but when I add them together, I still get the same answer. So commutative property is switching the order of your numbers, okay, but you will still get the same result. Now, another thing to keep an eye out for this, well, I guess when you're answering questions about this property, is to make sure that your numbers are the same. If I had something like 1 plus 2, and I wanted to switch my order, if I have negative 2 plus 1, this negative 2 is not the same as a positive 2, right? This 2 is positive, it's not negative. So these two would not be the same, and this is not an example of using the commutative property. So just double check your numbers to make sure that all of your signs are the same. Okay, the second property is called the associative property of addition. The associative property is where your numbers stay in the same order. And here we are going to be moving parentheses around in our problem. So what that looks like is something like this. Okay, I have 2 plus 7 plus 10, 2 plus 7 plus 10. Notice my parentheses in this first one are around my first two numbers, and then in the second one all I did was move my parentheses to the very last two. Okay, so when you're seeing a commutative property example, this is where your numbers are not moving around and the only thing that is changing are those parentheses. Okay, so associative, think parentheses. If you see parentheses in your problem, more than likely you are using the associative property. So a side-by-side comparison of the two, commutative is changing the order. Okay, so commutative, the order changes, and associative order does not. Commutative, it does not have parentheses. Associative is all about those parentheses. And regardless of which property you are using, you are going to have the same answer. Okay, and then here's just two examples of what those could look like. Alright, on to some workbook problems. Here is our first question. We want to consider the equation 3/8 plus 5/6 plus 1/2 plus 7/24 equals 2. Which of the following equations correctly applies the commutative property of addition given the equation? Select all that apply. So here we're using commutative property. Okay, so this is where you need to know commutative is switching around the order of the numbers, but all my numbers stay the same. That means that any of these answer choices that have fractions that are not in my original equation up here are automatically wrong. So this one that has that 1 in it, it's not that one because there is no 1 in my original equation. This one has a 3/24. But my equation needs to have a 7/24. So this one is not correct. If I look here, this one has a 1/4. There is no 1/4 in my original equation, so that one is incorrect. And if I look at all of the other options, they all have the same fractions. They're just all in a different order. So those leftover 3 that I have would be all correct. Those would all be equivalent using the commutative property. Our next one, we want to know, according to the associative property of addition, 1 plus 3 plus 10 is equal to which of the following expressions? So I'm going to rewrite this, and I'm going to put my parentheses here. Remember, associative property is just moving your parentheses. You're not changing anything in the problem. You're literally just shifting your parentheses. And notice here I am using this property of addition. So these these answer choices that use those multiplication signs, those are not correct. Okay, because I'm not multiplying here. Nowhere in this original expression do I have multiplication. And when I'm moving my parentheses, I could move them slightly over to where I keep my numbers in the same spots, and I'm just going to move them over to the next two numbers. So correct answer here would be B. Alrighty. Which of the following solutions uses the commutative property of addition to correctly calculate the total? Hint, correct answers will use the commutative properly and have the correct solution. Select all that apply. So here, the best advice I'm going to give you is to just type these into a calculator to make sure you get the same answer both times. Okay, for me that's the fastest way to do this. Another thing to notice is that we are asked to use the commutative property, right? Commutative does not include parentheses, so these two answers that show parentheses, I know that I'm going to mark those off straight away. I know I'm going to mark those off right away because I'm not using associative, I'm using commutative. So with that being said, let me pull up my calculator here and let's start checking these one by one. So notice how they're broken down with these equal signs, right? This equal sign is like the halfway point. So I need to see if this side of this equal sign is equivalent to this side, and I want both of them to equal 4. Okay, so I'm going to start with the first three, which is 2 plus 4 minus 2. So that's 4, that's good. 2 minus 2 plus 4. 2 minus 2 plus 4. That also equals 4. So both sides of my equal sign here equal 4. So B is going to be an answer I want to choose. Let's check our next one. Negative 3 minus 10 plus 13. This equals 0. Automatically this one is wrong. It should equal 6. However, it equals 0. So C, that is not what I want. Let's check our next one. I have 6 plus 9 minus 6. This should equal 3. Does it equal 3? No, it equals 9, right? This tells me at the very end that it should equal 3. So, I know D is also not correct. Now let's double check E just to make sure that we are not missing anything. I'm going to type this in using my number pad. So I have negative 5 plus 14 plus 7 equals 16. 14 plus 7 minus 5 equals 16. Perfect. So those are the two answers for this problem that are equivalent to using the commutative property. Our next one here, this one's a bit of a doozy, but it's not too bad. You just have to break it down into parts. So in 6.3, they introduce you to what is called the distance formula. Okay, your distance formula in 6.3 looks something like this. So it is A minus B, and these bars on the side, those are absolute value signs. Absolute value signs. Okay, and if you don't know, absolute value signs make any number that's inside of them positive. So say I had the absolute value of negative 7. Those absolute value signs would turn it into a positive 7. If I had the absolute value of 5, well, 5 is already positive, so my final answer would just be 5. Okay, so that is what those absolute value signs do. Knowing that, let's look and see here what Naomi is doing. So Naomi wants to calculate the distance between 3 and 2/5 and negative 4/5 using absolute value. And she does the following work. So this here is her equation that she comes up with. And she says that the distance between those two numbers is 2 and 2/3. Is she correct? Why or why not? Well, this is where you have to be extra careful. Okay, I'm going to take those two numbers that I have at the beginning, this 3 and 2/5 and negative 4/5. So my A here is 3 and 2/5. My B here is negative 4/5. I'm going to plug these into this equation here. So I'm taking this A and I'm rewriting it here. And I'm taking this B and I'm going to rewrite it here. Okay, keep my absolute value sign. A is 3 and 2/5, my minus, and then I have a negative 4/5. So if we look at our equation compared to Naomi's up here, ours has that extra negative, right? Which means that when Naomi was substituting her numbers into her distance formula, she forgot that extra negative. Maybe she thought that minus sign counted as the negative, but it does not. Okay, it's very different. So no, Naomi is not correct. She is incorrect, and she set up her original absolute value expression incorrectly. Oh, sorry, she did not set up her original absolute value expression correctly. So knowing that she didn't set it up correctly, the distance between these two numbers is going to be different. So part B is asking us, well, what is the distance between these two? Now this is where that calculator that we have been using comes into a big play here, because this looks like a lot to handle, right? If I hit this A button with the bars around it, this is my absolute value sign. So if I can click that, I'm going to do 3, a space, and 2/5 to get that mixed number. And then I have minus, and I'm going to type in that negative 4/5, and oops, I'm going to make sure my cursor is in front of my fraction, and I'm going to hit enter. Now it says it's 4.2. I don't have decimals here, right, but I can convert this to a fraction. When I convert it to a fraction, I have 21/5. Okay, 21 goes into 5 4 times, and I'm left with 1. So the correct distance between these two numbers is going to be 4 and 1/5. So this one was a lot just because of the way that it was shown with the two parts and the mixed numbers and those absolute value signs, but hopefully going through it now it's not too bad. And then our last question here. So we have this thermometer and we want to know which one of these answer choices correctly describes how to find the distance between these two temperatures. Okay, remember that I need to use my A minus B. Okay, and I have a negative 1/2 and I have a negative 4.8. So that would mean I'd have negative 1.2 minus negative 4.8. Okay, the most common mistake I see is students forgetting to put the second minus. If your second number is negative and you're dealing with this distance, you need to make sure that you have this second negative in here. Now knowing that, I can look at this equation and know it's wrong, this one and know it's wrong, this one looks good, this one is wrong, and this bottom one also looks good. The next part we need to figure out is our distance 3.6 negative 3.6 or 3.6. Here's a hint for you. Remember that our equation is inside these absolute value bars, and absolute value bars make every answer always positive. Okay, so if we see absolute value, I know my final answer needs to be positive, and this 3.6 down here is where my positive answer is. So on this one I was looking for two things. I was looking for the right equation, which we have here, and a positive distance. Alright, that is all that I have for lesson 6. Thank you so much for watching. If you have other questions, please let me know.